Hello and welcome to Spaced Out. I'm Sarah Begum, and today it's my great pleasure to introduce Professor Chris Welch. Chris is the Professor of Space Engineering at the International Space University. He started his career as a space scientist on the Giotto and Ulysses space missions, and later focused his attention on space propulsion, microgravity, and planetary exploration. He has been awarded the Sir Arthur Clarke Award for Space Education, and he sits on almost every notable space advisory board you can think of. Welcome, Chris. It's great to have you on the show.
Thank you, Sarah. Thank you for inviting me.
I'm really excited to know about your background and your views on space education. Having amassed a wealth of knowledge from your research and roles over the years, you're now sharing this with eager students. Why do you think space education is important now more than ever? And why should more students be encouraged to study and opt for a career in the space industry?
Well, fundamentally, I believe that humanity's future, is in space. I guess that's my basic position that we can't afford to have us all living on one planet. I guess I would agree with Elon Musk when he says that we need to be a transplanetary species. As long as we all stay in one place, the chances of something bad happening to us, that we can't recover from, is increased. So it's a form of insurance, I suppose. And I have a strong emotional commitment to the idea of space exploration. The Apollo 11 landed on the moon when I was 9 years old, and that set me on my kind of current trajectory. So I am one of those kind of children of Apollo who was inspired by the moon landings. And I'm disappointed that we haven't been back to the moon in terms of sending humans, gone to Mars yet, and all the rest of it. And so one of the ways that I can, assist with the global space endeavor is to try and create the next generation of space leaders, space innovators, space entrepreneurs, by teaching them about space and trying to make them as good and effective as they can be. So that's basically why, in terms of formal education. Then there's what I would call space education and outreach, where you're communicating informally, and that's to convince members of the public, politicians, decision makers, people with access to relevant resources, that they should be investing in space. I'm a very long-term member of the British Interplanetary Society, one of the oldest space societies in the world, set up in the 1930s by Sir Arthur Clarke, amongst others. And its motto is "From Imagination to Reality." And I believe that, particularly in the space area, there is what you might call an imagination gap. Certainly for members of the public and people who aren't in the space sector, and they don't understand what is possible. And through education and outreach, you can also reduce the size of that gap and show people that space is a domain in which you can work or you can invest, and which we can do new, innovative and exciting things.
As a member of the European Commission H2020 Space Advisory Committee, how significant would you say Europe's role within the space sector has been in comparison to its global counterparts? And what advice do you have for European space endeavours?
Well, I'm not a member of that advisory group anymore. My term there has finished. Okay. But when we were meeting, our focus there was trying to advise the Commission, particularly to support entrepreneurship. And I think that's one of the big changes in the space sector. 20, 30 years ago, I could name all the space companies, in the world, just out of my head. Now there are so many of them, and there are so many startups that are being created, that it's impossible to know them all, which is a good situation to be in. And so I think that's part of the kind of transformation. Government, whether national, transnational support is still needed in the space sector. But what has changed is it's possible to set up your own space company, and if you identify a good business case, to make money. And this creates an ecosystem which then allows lots of possibilities to be explored. And even if some of those entrepreneurial companies don't succeed, they have at least tried. I mean, for example, at the moment in the world there are many tens of companies working on small satellite launch vehicles, and they can't possibly, all succeed. The market is not there, but we don't need all of them to succeed. We just need a few of them to succeed and to bring the cost down, and do something similar for CubeSats and small satellites, as Elon Musk has done for bigger payloads. So we're expanding our range of capability. We're making it easier for people to send things to space, to send people to space, and I think that's a very exciting thing. I just wish it had happened 30 years ago.
It will eventually happen, and soon sci-fi will become a reality. I'm looking forward to those days. Do you sit on the board for the Initiative for Interstellar Studies still?
I'm on the advisory committee for the Initiative for Interstellar Studies, yes.
Okay.
I mean, that is now I4IS. It's one of a number of interstellar-related organisations in the world. And I have to say, interstellar travel is, out on the kind of speculative end of things. There are things that are relevant here and now in terms of economy, but I think it's important, and this comes out of the British Interplanetary Society viewpoint as well, that you always need some people looking way downstream into areas that other people might consider are so speculative as to be, irrelevant in current terms.
Yeah.
But I think there's a need for people to be thinking, well, how do we travel, potentially from one star to another? What do we need to do that? What preparation work could we be doing now to make that more likely? So that's kind of long range kind of strategic thinking.
No, I'm fascinated with interstellar activities and spacecraft that are sent out to interstellar exploration. It's fascinating. How will this subject shape the future of space exploration?
Well, it's going to be potentially quite a while before we can send any significant spacecraft on what I would call a proper interstellar journey. And I would differentiate what I would call near interstellar and actual interstellar, because you can sort of draw a circle around the solar system and say, once you cross this line, you are in interstellar space. And some people would call a mission to that area an interstellar mission. Whereas I would say, well, no, that's just a mission where we've stepped out of the solar system. To be interstellar, you actually have to travel to another star, or at least an appreciable way. So we do have some spacecraft which are, arguably, outside of the solar system now, but I wouldn't personally class those as interstellar. But nevertheless, as we extend, the sphere through which we explore, we will learn, more and more. And there are plans for what could be genuine interstellar spacecraft. Breakthrough Starshot, a plan to potentially send super small spacecraft, literally the size of a postage stamp, on laser-propelled solar sails to Alpha Centauri.
Maybe like
yes, incredibly small spacecraft.
I don't want you to mark this. It's just been using super glue and tea lights because of the aluminium and trying to make spacecraft. I made something called the Lotus, which cleans up space junk and points lasers at different parts of the Earth. But it's...
Pointing lasers at the Earth is always going to be a slightly controversial topic.
No, in a good way. Good lasers, like healing light.
This is part of the problem with some of these projects for interstellar flight, because you do need very powerful lasers. I mean, the plan is to launch these postage-sized spacecraft, postage stamp-sized spacecraft, on small solar arrays, and to shine very intense laser beams on them and to accelerate them to about a quarter of the speed of light very quickly.
Oh, wow.
In which case they will then take a couple of decades to get to Alpha Centauri, and then they will fly through the system taking photographs, and somehow, problem yet to be resolved, transmit that back over interstellar distances. And so there are a lot of unresolved technical problems, but that does at least offer the opportunity for an interstellar mission of some sort. But once you start talking about sending anything bigger or sending people, then it gets really complicated.
Wow, that's really interesting. I would love to see the development of such spacecraft. Based on your background in spacecraft engineering, you have a PhD in, and which you also teach in your current post. What are we likely to see an advancement in terms of space engineering and spacecraft design? Was it this interstellar space missions that you just mentioned, or would it be for something else in the near future?
Well, I think there are various steps along the way to to interstellar missions, and from my point of view, anything we do in space is all good. The first thing is getting off the planet, and that's why some of the developments like Elon Musk's Starship are so interesting. If he is successful, he will develop the ability to take large payloads into space relatively cheaply, and so that will be a big enabler, very disruptive to the existing launch situation. But that will enable us to do a lot of things in space. But even so, we really need to develop the ability to use resources in space. We need to look at using resources on the moon, using resources in asteroids and so on, to enable our space activities. And it's a step-by-step process. From my point of view, it has to be evolutionary. So we have to develop more activities in low Earth orbit, then activities on the moon, then throughout the rest of the solar system. And then ultimately, potentially, we may be in a position to build spacecraft which carry people, first of all, to the outer part of the solar system, and then beyond. And there are two basic trends that need to happen. One is better propulsion systems. So, for example, a fusion propulsion system would allow you to travel around the solar system, in a matter of weeks, if it's powerful enough and you have the reaction mass. And then the other thing is making better technology more reliable, for example, and smaller. So one of the big things that's enabled current developments in space is just the development of electronic technology. Things have got smaller. So it's easier to launch them into space. But for example, if you want to have people living in space for long periods of time, you need very, very reliable environmental life support systems. One of the options for interstellar travel is what's called a generation ship or a world ship. It travels very slowly because it's very big. And people are, born on that ship, they live on that ship, they die on that ship, they have children and so on. And it could take, 1,000 years to get to another star. And you're effectively talking about a very large tin can with people in it, away from the sun, between the stars. The only mass and resources you have are what you take with you. So you have to be, A, very good at recycling, and B, you have to be sure that your life support system will not break down. And that requires a level of understanding of ecological engineering that we don't really have yet. And you couldn't ethically send a human long duration mission off unless you were sure that you could keep them alive. There are other solutions to interstellar travel. There's the suspended animation one. You see these in science fiction films. People go into the pods and you go to sleep, and the spacecraft runs automatically for however many years it takes to get there. There's those sort of options as well. But who is going to do this? Why are they going to do it? Would be incredibly expensive. Nobody could afford to do those sort of missions at the moment. But you have to think about these things now. The British Interplanetary Society, again, back in the 1930s, was thinking about space flight, thinking about travel to the moon, at a time when everybody thought that was crazy. So, you always need some people out there, on the edge. But you can't have everybody out there, otherwise nobody's doing the the routine stuff. So you've got to have both.
One of your research interests is in space propulsion. How do you think space propulsion will work in the future in terms of sustainable methods?
Well, I would draw a distinction between propulsion for getting off the Earth and propulsion for use in space. Now, in terms of propulsion for launch vehicles, there's already been quite a big move, in that direction. Many of the older launch systems that originally go back in their heritage to the 1960s used fairly unpleasant chemicals. And if you look at the total environmental impact, including not just the launch and the dispersal into the atmosphere, but also the cradle to grave processing of those chemicals, they're clearly not very friendly. But one has to look at all the impacts. I mean, the space shuttle, when it flew, used liquid oxygen and liquid hydrogen as its propellants, and when you burn those together, you get water. And people go, well, water's good, isn't it? That must be a good propulsion system. But when you actually look at what happens when you inject water vapor, high up in the atmosphere, it can have a disruptive effect. Even if it's just water. And you can imagine that if you had a series of space shuttle missions, launching as regularly as they had hoped when they originally developed it, it would not have been good. So you have to look at all the impacts. I mean, ultimately, the best way to get to space is to go by lift, the orbital elevator, where, you go to somewhere on the equator and there is this enormous tower / tether going up into space, and you get into an elevator and it takes you up to space. And that way you don't need rockets at all. But those sort of systems are extremely speculative. I mean, people are working on them even now, but be difficult to build, and also, not without their risks as well. But that would be a very mature way to get things into space. Then when you get into space, then sustainability may mean different things. If you're in space, there is no ecosystem to immediately worry about. So you can maybe do things that you wouldn't do on the Earth. And a good example of a current topic that has popped up again is what's called nuclear thermal propulsion. Nuclear thermal propulsion basically uses a nuclear reactor, and you pass hydrogen through through and over the nuclear reactor, heat up the hydrogen, and expand it through a nozzle, and you get a good level of thrust, a good level of propulsion. Disadvantage is that you're using a nuclear reactor, which has safety concerns. In the longer term, you've got to protect the crew from the radiation. But there are many people who look at interplanetary missions and think that if we are going to send large numbers of humans, that we are going to have to develop nuclear thermal propulsion. But of course, if we were to develop fusion propulsion, then that would go out the window. And there's a big kind of question about fusion propulsion. There's a question about nuclear fusion in general. Ever since I was a teenager, people have been talking about how wonderful it will be when we have nuclear fusion to deliver power. It would be zero carbon power effectively. And those people who are a bit more cynical, have been quoted as saying, nuclear fusion is the power source of the future and always will be. Meaning that people have been working on it for decades and we still don't have nuclear fusion. There are some signs that there may be some, breakthroughs about to happen in terms of, compact nuclear fusion plants. If you had those, and as I said again, and then you had a nuclear fusion rocket, then you would have something a little bit more akin to what we see in the science fiction series The Expanse. Although they've taken a few liberties with the Epstein drive in The Expanse for the purposes of plot, but it would enable rapid transport around the solar system.
That's fascinating. What experiments would you like to see conducted in microgravity that have not yet been carried out?
Oh, lots and lots and lots of experiments. Too many to mention, really. A very large part of those would be biological experiments, whether on, and I'm not a biologist of any sort, but both on humans and on animals, and on plants, because the way that the microgravity environment affects humans and living organisms, we still do not fully understand. And if we are going to send people out into space for long long periods of time, to live in space stations or to live on other planets or on the moon, we really need to have a better understanding of the potential effects. I mean, we're probably some way off having the first baby born in space. Mm-hmm. But I mean, there is a serious ethical concern there. What happens if a child is born in space? What will the space environment do, to their development, while they're a fetus, and then, as they start growing up? And
you think we can adapt to microgravity as a species?
Possibly. I mean, we don't know. I mean, there are many science fiction, tropes around this where, the idea of the people who live in space all the time, become incredibly thin and scrawny and can never, never come down to the surface of the Earth, and so on. And that's a possibility. But the question is, might there be any, long-term, disbenefits in health terms? And the short answer is we just don't know at the moment. And so before we start having many people, live in space and work in space, we need to find out more about that. And similarly, if we want to have, biological, environmental life support systems, we need to understand how varying gravity levels, how varying radiation levels could affect those too. But there are equally many other interesting experiments to be done in microgravity physics, materials science. One of the interesting things at the moment is how it's suddenly in the last 5 to 10 years become much easier to actually do some small-scale microgravity experiments, and that's entirely due to the International Space Station is the first part, but secondly down to commercial access to the use of the space station, whether through companies such as NanoRacks in the US, or SAS and its IceCube service in Europe, or Space BD in Japan. It is now possible, if you have the money, to design your small experiment and to give them some money and for it to fly, almost just like a customer service. It's like whether you consider it expensive or cheap.
Yes, with wings or with rocket propulsion.
Yeah, I mean, you can send a 10 by 10 by 10 cube of about 1 kilogram to the space station for about 50,000 euros. So.
Oh, I got my hopes up there. More specifically of an aluminium projects coming soon. So you have published 90 papers and book chapters in conferences. What has been your most thought-provoking piece and why?
I think out of all the papers that I have ever written, the one that appeared to stimulate the most reaction was a paper on extraterrestrial garden design.
Oh wow, that is interesting.
I think largely because people were surprised that I, as a sort of physicist engineer, was A, thinking about this, and B, publishing a paper on it. This comes back to my kind of, I guess, science fiction, slightly geeky roots. At that time, which was, about 25 years or so ago, for reasons I won't go into here, I was hanging out with garden designers quite a lot, and landscape architects and so on. And my idea, I realised, of a garden was very British. It was kind of grass, rose bushes, that sort of thing. And talking to them, I realized that when they say the word garden, they meant something very, very different. It could be, British style garden, but, it was fairly clear that the concept of a garden was very culturally dependent, historically dependent, who you were, where you grew up, what you considered a garden to be. And some of those garden designers said, well, you don't actually have to have plants in a garden. It can just be a hard landscaped garden, or it could be concrete and moss, and so on. And in Japan, for example, there's this concept of a moss garden, which is just moss. And so that got me thinking, well, okay, if a garden is so culturally dependent, what would a garden mean in space, on a space colony, on the moon? So I started trying to come up with some conceptual ideas to to describe those. I mean, I'm still being, so here I am looking at garden design, but I'm still being a scientist about it. I'm trying to come up with, a model to classify gardens, and so I came up with a number of kind of metrics, if you like. One is time. Is it what I would call a fast garden or a slow garden? Does things change? Because one of the important things is there has to be some element of change, I think, in a garden. And then the amount of human intentionality. What's the difference between landscape, which is just what you find when you go out, and a garden, and the difference is there. One is human mediated, human curated, and the other is, quotes, natural. Although when you come to look at it, there are very few completely natural landscapes around now. Humans and life have generally affected them. And so I came up with this, this model, and then started thinking about, different sorts of gardens. At the end of it, one of my life's ambitions, which I'm sure I won't get to carry out, would be to go to the moon, travel to the moon with a rake, and make a Zen garden on the moon.
That's so cool. I love it. I hope you do get the opportunity to do that.
Yeah, barring a slightly extended lifespan, I think it's a bit unlikely. But even if I plant the seed and someone else does it in the future, that will be good. But yes,
project.
but some of my engineering colleagues obviously thought that I had gone a little bit strange in the head.
You can never be strange in the head.
But as far as I know, I could be proved wrong. I think that was probably the first paper on extraterrestrial garden design. It's there are many other papers on other aspects of engineering, but So if anyone watching the podcast knows of an earlier paper, let me know, and I'll stop saying that. But for the time being, I think it was, certainly an early paper on that topic.
No, there probably will be many. And I think after watching this, maybe you inspire someone to do it. Who knows?
Well, I look forward to that.
A gardener watching this, with a space enthusiast gardener. You never know. Many have referred to the moon as being a type of outpost for humanity to further explore space from. In terms of mining on the moon or moon villages and so forth, what kinds of constructions are we expected to see on the moon, and what will their purpose be?
Well, the purpose will I think drive the actual structures, and that then will depend on who is doing it. For example, there is this Moon Village Association, which I'm on the advisory board of, and what they are looking to do. I mean, the Moon Village term was a term.
I didn't know there was one. That's so cool.
Yeah. Oh yes, there is a Moon Village Association. But the term Moon Village was one that was popularised by the Director General of the European Space Agency, Jan Werner, and it got picked up a lot by the media. And I think it was interpreted, people would view this as a form of space settlement. Now that is not actually excluded, but what was really being proposed was something a little bit different from a village. I think a potentially more accurate phrase would be a sort of, open access international cooperative framework for mutual lunar activities. Basically the idea was that we should all go to the moon, we should all do what we can on the moon, and we should work out how to work together while doing it. So rather than it being some big international lunar program, pyramidal, top down, the idea was to encourage people from around the world, different countries, different companies, to go to the moon, but to try and have some level of coordination, interoperability, and so on. And the Moon Village Association exists to promote that idea. People still will say, oh, the Moon Village, that's an ESA concept. And the answer is, well, no, it isn't. It's just because it was associated with Jan Werner, because he gave it a lot of publicity, put his print on it. But the Moon Village Association is a completely independent organisation that seeks to promote, these sort of lunar activities. And I hope that we are going to see some of these sort of things going, but there is still a lot of international discussion going on. Geopolitics gets into this. On the one hand, you have, the USA, which is planning to go back to the moon, nominally in 2024. I think that's a bit unlikely to be able to meet. NASA hasn't actually been given the money to do that. Through no fault of their own. As a result of that, this Artemis program, the USA has signed with a number of national entities in support of the Artemis program and the international cooperation that the USA would like on this. The USA has signed a number of bilateral agreements with different countries, and these are called collectively the Artemis Accords. And so you have this group of nations who say, yes, well, we're going to go to the moon based on this, but equally you have another bunch of countries who are not interested in signing the Artemis Accords because they say this is, the USA attempting to steer things in the direction they want it to go. So the Chinese and the Russians, they don't want to sign the Artemis Accords. So then the question is, how will development on the moon go? Chinese, for example, have a very ambitious space program, as we've seen, just recently with them, returning rocks from the moon.
Yeah, the Chinese.
So if there's going to be a Chinese moon base, they will develop their moon base with their technology, and they will send it where they decide to send it on the moon. Conversely, at the same time, on another part of the moon, there may be people looking at different approaches. The classic model of a moon base at the moment is a series of tubes and cylinders which are connected together, each performing different functions, which then may be covered over with regolith to protect from the radiation. Or you could potentially bury them underground. But there are other models. You could have people who looked at inflatable structures. But a lot of interest in America and in Europe at the moment is in 3D printing once you get there. So you send robots there. They would dig up the regolith. They would process it, and then they would use it to build structures. So you can see you have a very different approach there. Alternatively, also on the moon, there are what are called lava tubes. The moon used to have some volcanic activity, and you see this same sort of structures on Earth in places where there are volcanoes. These are places where lava has flowed and it's built up a kind of tube and then stopped, and then you end up with this basically underground tunnel. And that would be, some people say, a good place to build your moon base because it's protected from the radiation. You don't want to be on the surface if you can avoid it. You may have to be, but the moon has no magnetic field. So in the event of a coronal mass ejection, a solar flare, here on Earth we are moderately well protected by the magnetic field. If you're on the surface of the moon, on the surface of Mars, or in deep space, you're not protected. So you do have to worry about radiation. Being underground, is safer than being above ground. This might mean that on the moon, in the future, the penthouse apartments would be the ones deepest underground, not the ones highest up. The cheap accommodation would be the stuff close to the surface. So, we'll see about it.
Blows my mind. Your other research interest involves planetary exploration. So in one of your papers, you mentioned searching for traces of microscopic life forms in the atmosphere of Venus. If we were to discover alien life forms on other planets, in what capacity do you think it would exist?
Well, I suspect that whether it's Venus or Europa or Mars, it would be some microorganism. We still don't really have a very good handle on how prevalent life is, but there's a certain amount of evidence which might mean that it's more prevalent than we think, but it's very difficult to detect. And there was that recent announcement about Venus and the detection of chemicals in the atmosphere, which could be interpreted as a sign of life, although now that's looking less likely. We do know that life is much more robust than we might have thought, 30, 40 years ago. And so, whether it's, in the atmosphere of Venus or, under the surface on Mars, there could be some form of extremophile, which is a microorganism that survives in extreme places, such as on Earth. You find them at the bottom of the ocean in volcanic vents, where they basically survive from the geothermal heat. Most of the life on Earth ultimately derives its energy from sunlight. There are some forms of life that will either extract chemicals or to use heat, and we may see similar things on other planets. But the problem is knowing how to detect them, particularly if you're sending a spacecraft there. Okay, you can come up with ideas of biosignatures that might indicate this, but it's difficult to know in advance. I look forward to more missions happening and us getting more information about this.
You've worked on the space missions, Ulysses and Giotto. What was your role in each of those missions, and what part of it yielded the best discoveries for you?
Well, those missions, those were right at the beginning of my career, a very long time ago. So at that time, on both those missions, I was working at the University of Kent, and I was what's called a research associate. I had done my first degree, I'd done my master's, and so this was my first job, and I was working in what was then called the Unit for Space Sciences. And on both of those missions, the interest of the Unit for Space Sciences, at that time, was in terms of cosmic dust. There are fine particles, out there in space, left over from the formation of the solar system, obviously in things like comets. So the Ulysses mission was primarily a mission to research the sun. But in order to fly over the north and south poles of the sun, it had to travel out to Jupiter first, and then use Jupiter's gravitational attraction to swing it up and out of the plane of the ecliptic so it could fly over the sun. So as well as carrying lots and lots and lots of solar-related science, it carried an instrument for detecting cosmic dust impacts. It was about so far across, and if a dust particle hit it, it would vaporize and turn into a plasma, and then the instrument would analyze the plasma. So that was one experiment, and then on Giotto again, that was much more focused on cometary science. It was designed to fly through the tail of Halley's Comet. And I was working on an instrument there called the Particulate Impact Analyzer, which was again to detect dust impacts, which would then vaporize into a plasma and be analyzed by a mass spectrometer to work out what the elemental aspects of it, what the dust was made up of. Although I worked on those, I later left that and went to become a space engineer by doing my PhD, and so I wasn't around at the time that all the data started coming back in. My former colleagues there got a lot of interesting results, but by that time I was working in a different area.
Do you have plans to work on any future space missions in terms of being part of the engineering of the spacecraft side of things?
Yeah, at the moment, my major focus at the International Space University, apart from being the program director of the MSc there, we have what we call the Space Payloads Laboratory. And so, yes, it does what it says on the tin. It's about flying payloads in space when we get the opportunity. So we've had 2 payloads go to the International Space Station in recent years. We have 1 payload that is still there. The International Space University is an interdisciplinary institution, so we don't just do science and engineering, we do all sorts of things. So the 3rd payload that is still there is actually an artistic payload, which with one of my friends and colleagues, a Mexican artist called Naum, who is based in Berlin. So when we had the opportunity, we thought, well, what can we do? What can we put on the space station? And it is, I'm pretty much sure, the world's first interactive space kaleidoscope, which is in a little box about so big. And the way that works is on the ground, we have a little sensor that you can put your finger on, and it measures your heart rate. And it transmits your heart rate up to the space station into the payload. It makes the kaleidoscope turn, and there's some little floating objects in there. A video camera transmits the video image back to the ground in what we call near real time.
Oh, wow.
And so that allows somebody on the ground to, through their heartbeat, control this payload on the space station. So it's, we believe, again, the first interactive art payload on the space station. I like to try and write poetry from time to time. I also have a poem in that payload as well. it's because we have this rotating cylinder, and so around the outside of the cylinder there is this poem which I have written, and there's a little webcam that points at that.
Can you read a poem to us?
I can. You'll have to give me a couple of minutes just to find it.
Speaking of the Space University and space education, it would be interesting to know what hopes you have for your students in the future. What are you teaching them now that you'd like to see them implement in terms of space missions or engineering in the future?
Key thing about the International Space University is its kind of fundamental kind of ethos, which is what we call the 3 I's: international, intercultural, and interdisciplinary. Mm-hmm. So sometimes people, say, well, are you an engineering school? Are you a science school? Are you a business school? I go, no, we're a space school. Yeah, that's what it says. And so, whereas many space programs, educational programs, would focus on a particular, fairly narrow area, we have a very broad curriculum. So if you do an International Space University program, whether it's the MSc or summer school or whatever, you'll be exposed to, science, engineering, space applications, management and business, policy, economics and law, human performance in space, space humanities. So on a typical day, you could have a class on space ethics, followed by a class on orbital mechanics, followed by a class on on space law, or the psychology of spaceflight. So it's very, very broad. And the purpose of this is to produce people who can have sensible conversations with experts outside of their own areas, and also so they can see how all the big pieces fit together. For example, it's not going to turn a lawyer into an engineer. It's not going to turn an engineer into a lawyer, but they will be able to have, a good dialogue. And the engineer, if the engineer wants to set up, his or her own company, then they will know the sort of things that they need to take care of legally, and go and find some lawyers, and they will understand why they have to keep an eye on, international space policy and how this might affect their business. As far as what I want them to do, I don't mind. As long as they move things forward. So if they want to set up their own company, that's great. And a number of my students, have set up their own companies. If they want to become researchers in particular specialized areas, that's great too. If they want to be space artists, I'm overjoyed. It's all good.
Be a space artist?
Oh, there are space artists, absolutely. Space education for a changing world. That's our mission statement. But what I actually say to my master's students when I talk to them when they arrive is, at the end of this, I want you to go off and just do cool shit in space. I don't care what, but that's what you should be thinking about, and you get to decide what you do. But apparently, for corporate advertising purposes, we're not allowed to put that on our website.
No. Before we read the poem, before I get you to read the poem, I'd love to know your story briefly. What made you so interested in space and to want to work within the industry? How did it come about for you?
I got interested in space. I guess there were two things. Firstly, there was the Apollo landings on the moon, and that happened when I was 9 years old, and it was in the middle of the night, here in Europe. My father kind of woke me up, and made me take part in that. Although, strangely enough, we were in a tent in Austria at the time, so we listened to it on the radio. And I later tried to write a poem about that, but I was rather unsuccessful. So I have a poem which is about an entirely imaginary, experience which involves a television. So I have a certain amount of false memory syndrome as a result of that. There's the real memory and the one created through the poetry. So the Apollo moon landings were this very big, seminal experience for me. And then I think really, at the risk of sounding incredibly geeky, it was reading science fiction. I remember going into my local library and coming across some books by a science fiction author called Andre Norton, and she wrote loads and loads of what you would basically call, I guess now, kind of juvenile / young adult science fiction. Fairly slim volumes, but adventures in space. And then after that, I kind of graduated onto reading other science fiction, the kind of classic big three back in those days, Asimov, Clarke and Heinlein, and then, just reading lots and lots of other things. And I joined my local astronomy society, and I had a telescope of my own. I wanted to do, space. There were some very good programs on the television at that point about cosmology and theories of the universe. So it was all there. And I was trying to decide what to study at university, and was advised at that point to study physics as a good sort of general starting point. But even when I was on my physics course and I was kind of, talking about space, a lot of my classmates thought I was, a little bit touched. But again, I joined the British Interplanetary Society when I was 18 or 19, I don't recall exactly. And, I've been a member, ever since. And that, encouraged me. And it became apparent that it was possible to have a career in space, if you took the time to find out how to do it. And, that's really all I've ever wanted to do, was to work in the space domain. Ideally going to space if I could. I had a shot at being an astronaut about 30 years ago, but in the end I was let down by my left nostril. Nostril. What they call an occluded left nasal septum. That was for the Anglo-Russian Juno program that Helen Sharman ultimately flew on, but I got to Canada 24 or 25, I think, which was closer than I expected to get. I'm very keen on the idea of human spaceflight. I would like to see more of that, hence the involvement in Space Hero. Looking forward to seeing how that develops. Yes, I think it's an exciting and important field to work in.
That's amazing. And if anyone wanted to enroll in any of the courses in the International Space University, would they need certain qualifications, or ISU runs a master's program based in Strasbourg when we're allowed to actually go in the building. At the moment, sort of online, and for that you have to have an undergraduate degree. We're fairly open about the exact topic of the degree, so it doesn't have to be technical. My first year as program director, I had one student who had a PhD in computational fluid dynamics, and I had another student, and she had a degree in tourism. So you can see we accept a very wide range of people. For our summer schools, you have to for the 9-week summer school, the SSP, you have to have graduated at least, and then there's a school that runs in Adelaide in Australia, our Southern Hemisphere SSP, which runs for 5 weeks, and for that you have to have completed the first 2 years of academic study at undergraduate level. We're open to all sorts of people from all sorts of places. We try very hard to balance out the disciplines and balance out the nationalities, the genders, as well, to get as diverse a class as we can. That said, inevitably there are still quite a lot of engineers, but it's getting better every year. I would love to wrap this up with your beautiful poem, which I'm really excited to hear.
Before I read the poem, I should maybe do a little bit of explanation of it. So it's effectively a site-specific piece. It was designed to complement this interactive payload on the space station. This kaleidoscope, which is controlled by the human heart rate from the ground. And at the same time, it was unusual for a poem in which the dimensions of the poem were also constrained, because it had to fit around the outside of the kaleidoscope tube, which meant it actually turned out to be a very long and narrow poem. It had to fit in a long and narrow box. I couldn't have long lines. And then I was thinking, well, I want it to reflect, space. I want it to reflect the payload, the kaleidoscope, try and reflect, the fact that it's controlled by the human heart rate. And there's a strong theme of circles in it, because the kaleidoscope turns, because the space station travels around the Earth, and then I chose a format, what's called a pantoum, which is a structure where you get a lot of repeating lines, and at the start of the poem features some of the same lines as the end of the poem. So it's intended to be a sort of circular, repetitive poem for that reason. So it's called Pulse. We must have motion, though we ascend to black sky. Born in Earth's blue ocean, we still feel its tides. Though we ascend to black sky, we orbit the Earth, we still feel its tides, the pull of our birth. We orbit the Earth, time gives us connection, the pull of our birth, our blood circulation. Time gives us connection, our round through the dark, our blood circulation, pulse's regular mark. Our round through the dark, the unbounded dimension, pulse's regular mark, drives our view of creation. The unbounded dimension, light's folding reflection, drives our view of creation, as without, so within. Light's folding reflection mirrors heart-driven turn, as without, so within, while distant stars whirl. Mirrors heart-driven turn, joining cosmos to ground, while distant stars whirl, our journey is found. Joining cosmos to ground, the movement goes on, our journey is found, the quest for beyond. The movement goes on, born in Earth's blue ocean, the quest for beyond, we must have motion. And that's it.
Wow.
Well, thank you.
Thank you. It's my first space poem ever.
Well,
Courtesy of yourself. Your story has been fascinating. Your knowledge is impeccable, and I'm inspired by everything you've just said to me today. And I've learnt so much. Thank you so much for giving me your time and coming on the show.
That's been my pleasure.
May you have a beautiful rest of the festive week. Don't eat as much as I do. And I shall speak to you soon, Chris.
Okay. Thank you very much, Sim.
Bye-bye.